in this picture, we have a right triangle already labeled. Why don't you pause the video and see if you can write down the values of all 6 trig functions with relation to angle A. Okay, so I'm just going to show you the way I would label them. So first off, when I find sine of A, I have 20 over 29. Just get my pen out. So 20 over 29. And so the next thing I would label is I would label cosecant. So since sine of A is 20 over 29, cosecant of A is its reciprocal, so that's just 29 over 20. In the same way, when I do cosine of A and I get 21 over 29, then secant is its reciprocal, so secant of A is 29 over 21. Lastly, tangent of A is 20 over 21, and cotangent of A is 21 over 20. So in my mind, I group these 3 new functions with the 3 I already know, and just think of them as their reciprocals. Really, it's just a matter of learning the words that go with it. So down here, we're going to connect what we did to the problems on the other page where we're given a trig ratio. So we're going to do this one pretty quickly together. So I have my same information, sine of x is 4/5. So opposite and hypotenuse are labeled as 4 and 5. If you remember from our Pythagorean triple, that this is a 3. So when I'm finding my ratios, I'm going to start out with sine of x, which I already really have, and I'm going to find cosecant of x at the same time. So my sine of x, as I said, I already have. It's not really one of my 5 answers, but I'm going to write it down to show the connection. Cosecant of x is 5 over 4. And then, so cosine of x equals 3/5, so secant of x is 5/3. And lastly, tangent of x, opposite over adjacent, is 4/3. So cotangent of x is 3/4. So why don't you pause the video and go ahead and try B. For some reason this didn't come through. I mean, I guess it doesn't like theta. That's supposed to be a theta, I believe, on your page. So pause the video and see if you can figure this one out. I'm going to do the whole thing with you on this one since it's slightly different. So I'm going to draw my picture. Kind of any of these problems I draw a picture, here's theta. Now I'm more comfortable working with cosine than secant, so I'm going to write this as a fraction. So secant theta equals 3 over 1. That tells me that the cosine of theta is 1 over 3 since they're reciprocals. So this is adjacent over hypotenuse. So I'm going to put the 1 on this side and the 3 over here. Using Pythagorean theorem, we did something similar to this, so we'll do this kind of quickly. We're going to find this side. So when I move my 1 over, 9 minus 1 is 8. And taking a square root here, radical 8 simplifies, 4 times 2 is 8, to 2 radical 2. So we're going to put that on here. So this problem doesn't ask for all 5 other trigonometric functions out of the 6. It just wants tangent of theta. So tangent of theta is going to be equal to the opposite side over the adjacent from theta. So I get 2 radical 2 over 1, which just equals 2 radical 2 is my final answer. Each day, we're going to add a little bit to our radian measures, which we're doing here, just because radians can be a little tricky, and if we do a little bit each day, it won't be so overwhelming. So here, my numbers are kind of weird. I don't know, they didn't go over to the PDF well. So this is a 90 of 45. These fractions are 1/4 and 1/2. I think you should still be okay to read them. So from the previous lesson, 90 degrees is equivalent to what radian measure? Just to review, the whole way around the circle is 2 pi, right? So halfway around the circle, so that goes with 360, let's write that in. 180 degrees halfway around my circle was 1 pi. So at 90, which is half of that, I'm going to have 1/2 pi. Okay, so I'm going to write that down. So 1/2 pi on our picture was equivalent to 90 degrees. Another way we can write that is pi over 2. That's basically just multiplying this out and making it pi over 2 if we multiply the top and bottom. Now, if we take that a step further, we saw 45. If I cut the 90 in half, if I cut 1/2 in half, I get 1/4 pi radians. okay? Because 45 is half of 90 and 1/4 is half of 1/2. So another way we could write this one is pi over 4. We'll kind of use these interchangeably. Ultimately, this form is what we use as we move forward, but the 1/4 pi kind of makes a little more sense to think about. So here our next thing says 30 is what fraction of 90? So if I think about it, 30 is 1/3 of 90. So if we want 1/3 of something, we would just multiply that thing by 1/3. So remember that 90 is equal to pi over 2. We'll use that equal to 1/2 pi. So pi over 2 times 1/3 to get 1/3 of this 90. Multiply across is pi over 6, which could also be written as 1/6 of pi. Using similar reasoning, 60 is what fraction of 90? So that's 2/3, right? 60 is 2/3 of 90. So if I take the 90-degree measure, right, which is pi over 2, and then multiply by 2/3, I could cancel these 2's, but I'm not going to show that right now. I'm just going to multiply across. I get 2 pi over 6, which is pi over 3. Okay, or it could be written as 1/3 pi. So I'm going to take each of these radian measures. I'm actually going to erase the 1/3 pi now just because that's kind of in my way of labeling, but that one is 1/3 pi. And I'm going to put those radian measures onto this quarter of the unit circle, okay? So 0 is 0, right? 90 is 1/2 pi. I'm going to use the fraction forms of everything here, so that's 1/2 pi. 45 is 1/4 pi, or pi over 4. 30 we just found is 1/6 of pi. And then lastly, 60 is 1/3 of pi. Remember, pi over 3 or 1/3 of pi. Now, just to kind of make this all go together, if we jump along by 30 degrees in this picture, we should have some sort of consistent counting pattern. So 30 is 1/6 pi. Then 60 should be 2/6 pi. And we do see that 1/3 equals 2/6. 90 should be 3/6 pi as we go 1, 2, 3, right? And 3/6 is equal to 1/2. So everything's logically consistent, and that adds a little bit of our radian measures in there.